we will see some more previous IIT questions in the concept atomic structure we will see. Okay. See the first one. The frequency of light emitted for the transition n equal to 4 to n equal to 2 of He plus is equal to the transition in hydrogen atom corresponding to which of the following? Corresponding to which of the following? What he said in the first line, he said that He plus 1 unit positive charge carrying helium. If in helium the electron is dropped from fourth energy state to second energy state, it has a frequency, certain frequency. That frequency is equal to, first we calculate the frequency of a He, frequency of a light radiation when the electron dropped from fourth energy state to second energy state in He plus. Okay. See according to hydrogen spectra, all of you know 1 by lambda that equal to mu by C equal to R Z square into 1 by N1 square minus 1 by N2 square. See here, I want a frequency. So, nu equal to R Z square. Write on C R Z square into 1 by N1 square minus 1 by N2 square. Here, C and R both are constants. Here, the helium He plus has atomic number is a 2 and N1 is a 2, N2 is a 4. Substitute the values. Cr, Z is a 2 means 2 square means a 4 into 1 by N1 is a 2 means 2 square 4 minus 1 by 16. That we will get Cr into 4 into, that is a 3 by 16. 3 by 16. That means 3 by 4. Cr into 3 by 4. Okay. This is a frequency of a light emitted from the transition of electron from fourth energy state to second energy state. Okay. Here in this hydrogen atom, okay, from in which transition the light radiation emitted have a same frequency. Here also the frequency nu equal to C R Z square into 1 by N1 square minus 1 by N2 square. Here Z for hydrogen is 1. Okay. So 1 square means a Cr is there. So nu Cr into 1 by N1 square minus 1 by N2 square. In these four options, the one which have a 1 by N1 square minus 1 by N2 square is a 3 by 4. Okay, that is released on same frequency light. So only you should calculate 1 by N1 square minus 1 by N2 square. This is the N1, this is the N2. So nu equal to, for first one, 1 by N1 square, 1 by 1 square minus 1 by 2 square, that equal to 3 by 4. Okay, so nu equal to Cr into 3 by 4. Okay, that means in hydrogen the electron is dropped from second energy state to first energy state. We emit a light radiation. It has a frequency equal to the electron dropped from fourth energy to second energy state of He plus. Both will be same. Now we will check remaining three options also. Here 1 by 2 square minus 1 by 3 square means 1 by 4 minus 1 by 9. That means 36. 9 minus 4. That is a 5 by 36. Not the second one. And check the third one. 1 by 3 square minus 1 by 4 square means 9 into 16. 9 into 16. 16 minus 9. That equal to 7 by 9 into 16. This is also not correct. And next, n equal to 3 to n equal to 1. 1 square, 1 by 1 square by 1 by 9. That means 8 by 9. This is also not match with the 3 by 4. So, in a hydrogen atom, the electron is dropped from n equal to 2 to 1. In that case, emitted frequency and the electron drops from 4th to 2nd energy state of helium have a same frequency. Which pair is an example of isoelectronic species? What is the isoelectronic meaning? Isoelectronic means same number of electrons. Same number of electrons. Okay, in the given options, the one which has one of the options have a same number of electrons. Okay, the ions, two ions have a same number of electrons. Okay, first of all, how we will calculate a number of electrons? Number of electrons means it is equal to the atomic number of a neutral atom. That means atom does not carry any charge. In that case, the number of electrons is equal to atomic number. If an atom carry positive charge, number of electrons is equal to cation, means positive charge carrying one. The number of electrons is the atomic number. That means subtract the how much positive charge is there. That means how much positive charge carried by atom, that is subtracted from the atomic number of positive charge, carrying positive charge. You carry 1 unit positive charge, subtract subtract 1 from the atomic number. If the ion carry negative charge, add the charge to the atomic number of negative charge. Okay, see here, in a given options, given ion, it is made up of two atoms. So first of all, write down the atomic numbers of two atoms and sum the two atoms atomic numbers. Here carbon has atomic number 6 and nitrogen has atomic number 7. And whole ion carry 1 unit negative charge. 1 unit negative charge means we will add a plus 1. So the total electrons is 6 plus 7 plus 1, that is a 14. Okay, like that calculate NO plus also. Nitrogen has atomic number 7, oxygen has atomic number 8, but here the ion carry positive charge. So how much positive charge it is? It has 1 unit positive charge. So positive charge is there, means subtract the positive charge. How much it is? 1. So 7 plus 8 minus 1, that equal to 14. So Cn minus has 14 electrons and NO plus has 14 electrons. Okay, both shows the same number of electrons. See here, Cn minus already we are calculated in the first option. Cn minus has 14 electrons. Calculate O2 plus. Oxygen, 2 oxygen atoms are there. Each oxygen has an atomic number 8. So 2 oxygen have atomic number 16. And here it carry positive charge. So subtract the positive charge. How much it has? 1 unit positive charge. So minus 1. 16 minus 1, 15 electrons. So both the ions are not a isoelectronic species. And see the option C, NO plus already calculated in the first option. NO plus has 14 electrons and O2 plus has 15 electrons. So it is also the two ions also not a isoelectronic species. So the isoelectronic species or Cn minus NO plus. Okay, go to the second one. Uncertainty in the position of an electron moving with a velocity 300 meter per second, accurate up to 0.001% will be uncertainty position. Okay, according to the Heisenberg uncertainty principle, we know a delta x into m delta v is equal to h by 4 pi. H by 4 pi. Either it is greater than or equal to. So we will take a equal. Here delta x is the position of the electron and m is the mass of electron and delta v is the velocity of electron and h by 4 pi. H already you know that is the Planck's constant and pi is 22 by 7 or 3.14. Okay, here what the Heisenberg uncertainty principle explains? It explains the calculation of exact position and velocity of electron at a time is impossible. So here we will using one of the term. That means if you know a velocity, we will calculate a position. Or if you know a position, you will calculate a velocity. Okay, here he gave a velocity. That is a velocity is equal to velocity of electron is 300 meter per second. 300 meter per second. And it is accurate up to, that means the change in velocity is 0.001%. So multiply the velocity with the 0.001 by 100. That the change in velocity is 0.003 meter per second. And the mass of electron is 9.1 into 10 power minus 31. And H value you know and pi value you know. So write down a formula for position. Delta x is equal to h by 4 pi m into delta v. Substitute the values and calculate the position of the delta x. That means the position of the electron. So h is a 6.625 into 10 power minus 34 joule second. And 4 into pi is a 22 by 7 into mass is a 9.1 into 10 power minus 31 kg into the velocity change is a 0.003 meter per second. Here the 7 cancels, 4 into 22 by 7 into 9.1 into 10 power minus 31 into 0.003 meter per. Delta x equal to 6.625 into 10 power minus 31 minus 34 joule second. Joule second we will write in a form of a kg. Meter square per second divided by the multiplication of all we will get 0.342 into 10 power minus 31. Here kg meter per second. So kg will be cancelled, meter and square will be cancelled and second cancelled. So we have a units meter. Okay, 10 power minus 31 going to a 10 power plus 31. That means 10 power is a 10 power minus 3 meter. Okay, 6.625 by 0.342 is cancelled. 19.87 into 10 power minus 3 meter. These are, see the next one. Write the electronic configuration of chromium. It has atomic number 24 and predict in it 1. Number of subshells, number of electrons in subshells having N equal to 0. And third one, number of electrons having N plus N value equal to 3. And fourth one, number of electrons in highest value of N. Highest value of N. That means here he asked the number of subshells. So write down complete full configuration of chromium. What is the configuration of chromium? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Is it right? No, 4s1, 3d5. Due to stability, the s electron jumps into d. So the configuration 4s1, 3d5. Okay. See, count the number 2, 4, 10, 12, 18, 19, plus 5, 24. Okay. Continue. See, number of subshells. Number of subshells. Here, 1s, 2s, 2p, 3s, 3p, 4s and 3d. How many subshells are there? 1, 2, 3, 4, 5, 6, 7. So, number of subshells in this configuration are 7. Number of electrons in subshell having L equal to 0. 2s, 3s and 4s are there. The number of electrons here, 1s has 2 and 2s has 2, 3s has 2, 4s has 1. So the total number of electrons are 7. 7 electrons are there. Next, third one, number of electrons having a N plus L value equal to 3. N plus L value equal to 3. Calculate the N plus L value. Here, it has a, 1s has a N value 1, L value 0. So 1, 2s has 2 plus 0, 2. 2p has a 2 plus 1, 3. 3s has a 3 plus 0, 3. And 3p has a 3 plus 1, 4. But here he has the number of electrons having the N plus L value equal to 3. Equal to 3, we should have 2p and 3s has 2p, 3s has N plus L value 3. Here 2p has 6 electrons, 3s has a 2 electrons. Number of electrons having the N plus L value equal to 3. How many electrons? 6 plus 2, that is 8 electrons. 8 electrons having the same N plus L value, that is a 3. And its number of electrons in highest value of N. Here in this configuration, 4 is the highest value of N. So it has a 1 electron. It has a 1 electron. See the next one. Write down 4 quantum numbers for electron present in 4f orbital. 4f orbital. What are the 4 quantum numbers? Principal quantum number N, azimuthal quantum number L, magnetic quantum number Ml, and a spin quantum number Ms. Okay. Here 4f means it has a N value 4. F orbital have a azimuthal quantum number, that is a 3. Ml, the possible values of Ml are minus 3 to plus 3, minus 3 to plus 3, including 0, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Any one is there, it has the correct magnetic quantum number. And Ms, it may be either plus half or minus half. In the ground state of chromium atoms, the number of electrons with azimuthal quantum numbers L equal to 1 and 2 are respectively. Now only we see. So write down the configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. This is a ground state configuration of chromium. Okay. In a ground state, it will be arranged like that, not a excited state. Okay, electron jumped, but it is a ground state configuration. So here L equal to 1 means a p orbital, L equal to 2 means a d orbital. So how many p electrons and d electrons are there? See that one. 1, 2. That means a 2p6, 3p6 means how many electrons? 12 electrons. L equal to 1 has a 12 electrons. And L equal to 2 means a d orbital, that is a 3d 5. So L equal to 2 has 5 electrons. 5 electrons. 12 electrons in L equal to 1 and 5 electrons in L equal to 2. Next one, which of the following statements are correct? Statements are correct. See the first one, electronic configuration of chromium is argon 4s1 3d 5, 24 chromium atomic number. Argon has 18, 18 plus 6, 24. So correct one. And already we know 1 to 30 elements. Chromium and copper have exceptional configurations. Okay, the electron, due to the jumping of a electron from s to d orbital, the atom get a stability. So that's why chromium and copper have different configurations. Chromium has a 4s1 3d 5, copper has a 4s1 3d 10. So the option is a correct one. And next, see the magnetic quantum number may have a negative value. Why they said a may means here if L equal to 0 S subshell, it has a magnetic quantum number 0 and L equal to 1 p orbital, it has a ml value -1 0 plus 1. Okay, except s orbital remaining p d f whatever there, they all have a negative magnetic quantum numbers. Okay, so that's why here he said the magnetic quantum number may have a negative value. Okay, that is also correct one. Next is option C. In silver atom, 23 electrons have a spin of a one type and 24 of the opposite type. Here the silver have atomic number 47. Silver is a which group element? That is a first B group in the periodic table. First B group. Copper, silver and gold are there. Okay, so copper have argon 4s1 3d 10. Silver has krypton 5s1 3d 10 and gold xenon 6s1. Silver has krypton 5s1 4d10 and gold has xenon 6s1 5d10. Okay, like that you will remember. First B group, copper, silver, gold. These are also called as a coinage metals because those are used in the preparation of the coins. So they have a like this. Here the configuration is a krypton 5s1 4d 10. Argon has a atomic number 18. Krypton has atomic number 36. So 36 plus 1, 37 plus 10, 47. Yes, right. Here in this 36, all are paired electrons. Means here krypton has atomic number 36. Means 18. 2 18s are 36. So 18 electrons have a plus half. 18 electrons have a minus half. And D, 4D have a 10 electrons. Means 5 electrons have a positive spin and 5 electrons have a negative spin. And go to 5s1. 5s1 means it has only one electron. It has shows either a positive or a negative. Containing in a positive. So 18 plus 5, 23. 23 plus 1, 24. 24 have a positive spin and 18 plus 5, 23 have a negative spin. So the option is a correct one. 23 electrons have one type of a spin and 24 electrons have another type of or opposite type of spin. Okay, correct one. So option A, B, C correct. See the option B. Oxidation state of nitrogen in HN3 is -3. Okay, All of you know hydrogen is the first group element. It has a +1 oxidation state. +1 oxidation state. Whole molecule does not carry charge. Take a 0. See here, I want to calculate oxidation state for nitrogen. So that I think it's hydrogen has a +1. So +1 plus how many nitrogens are there? 3. And each nitrogen has a X oxidation state equal to the oxidation state carried by the molecule, that is a 0. So 3x is equal to, here +1 coming to equal this side, carry negative, that means -1. So x equal to -1 by 3. -1 by 3. Wrong one. Next one, the wavelength associated with a proton moving at 1 into 10 power 3 meter per second is, okay, what he asked to calculate the wavelength of a proton. It has a velocity 1 into 10 power 3 meter per second. Okay, if you know now velocity, that means according to our de Broglie calculate. According to de Broglie, wavelength lambda equal to h by mv. Here, the velocity is 1 into 10 power 3 meter per second. And mass of proton is 1.67 into 10 power minus 27 kg. And H is 6.625 into 10 power minus 34 joule second. So substitute all values and calculate the wavelength. Lambda equal to 6.625 into 10 power minus 34 joule second. Joule second means kg meter square per second divided by mass of proton is 1.67 into 10 power minus 27 kg into the velocity is 10 power 3 meter per second. Meter square cancel, second cancel, kg will cancel. Here 6.625 by 1.67 into 10 power minus 27 and 10 power plus 3, 10 power minus 24. So 6.625 into 10 power minus 34 divided by 1.67 into 10 power minus 27 meter. 10 power 27 meter. 10 power, 24. 3 subtracted from these now. 10 power minus 24. Minus 24 going to our plus 24. So 6.625 by 1.67 into 10 power minus 34 into 10 power plus 24 meter. Okay, 10 power minus 10 is remainder. So lambda is equal to 10 power minus 10. 625 by 1.67 is a 3.96 into 10 power minus 10. 10 power minus 10 meters means angstroms. So 3.96 angstroms. 3.96 angstroms. Which of the following quantum numbers are not possible? See the option A. See N, L, ML and MS. N equal to 3. L equal to 0 means which orbital? S orbital. S orbital have a magnetic quantum number 0 and spin quantum number is a plus or a minus is a correct. So this is the correct one. It is possible. And go to the B, 2. N is a 2 and L equal to 2 means which orbital? That is a D subshell. So 2D. 2D is possible? Not possible. Okay. And next option C, 4 and L value 3 means it is a F. 4 F. L is 3 means the ML value is possible from minus 3 to plus 3 including 0. Minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Here minus 2 is there. So it is a possible one. And next D, 1 and L is 0 means S, 1, S. It has a possible magnetic quantum number value. S orbital has only 0. But here he gave a minus 1. So it is not possible. So option B and D are not possible set of 4 quantum numbers.